Determine the change in velocity of Claire's scooter as she turns a corner if she approaches it at 18.7 meters per second west and exits at 16.6 meters per second north. So again, we'll draw a diagram. So she travels in at 18.7 meters per second west and goes up at 16.6 meters per second north. Okay, our 0th step, use the opposite of the initial vector. So our initial vector here is this 18.7 meters per second west. So the opposite of that is negative 18.7 meters per second east. Okay, so we have negative 18.7 meters per second east, and we have 16.6 meters per second north. Okay, from here we can do them the same way we do the addition, head to tail. All right, but we just need to make sure they are around the right way. So there, negative 18.7 meters per second east, head to tail, 16.6 meters per second north. Let's go red. Okay. So again, we can use Pythagoras here. So we'll call it R again. R equals square root negative 18.7 squared plus 16.6 squared. And you'll see that that squared gets rid of the negative. Anyone got a magnitude there?
25.
25. On the dot?
Yeah.
Close enough? Cool. Okay, now we need a direction. Okay, so theta is equal to the inverse tan of opposite on adjacent 16.6. I don't know, will tan let you use negatives? I can't remember. Is that defined?
Negative 41.6.
Negative 41.6, that would mean that's just 41.6 in there. That's cool. Awesome. So, our direction, again, would be 0.4, so 47.4. Let's just do it. Oh, they're the same, aren't they? So, our direction is true 47.4 degrees. Oh, 48.4. Okay, so the important thing to realize here is you must use the negative or the inverse of that vector. And again, this makes sense. If we started traveling west and are now traveling north, the vector change, the change that happens is we must travel to the east a bit to cancel out this west. Okay, if there was no change horizontally, we'd go off at an angle somewhere. Okay, but our west direction has stopped entirely, and now we're going north. So to stop that west, our change in velocity must have an east component to counteract that west. Okay? So this is what I mean when you're doing vector subtraction. That 0th law, you have to use the negative of the initial vector. Okay? For everything else, anytime you're doing anything that's not velocity, just add them as you normally would. But when you have velocity, you need to use that negative.